Hi, I'm Vignesh, founder of Vistrux. I've been building Agentic CAD workflows inside AutoCAD, where I create systems to automate repeatable drafting tasks. In this video, I'll show you how you can set this up yourself, from downloading Claude Desktop to connecting it to AutoCAD and then building your first Claude skill. First, we'll download Claude Desktop. Then I'll explain the set framework which I use to create reliable automations. After that, we'll connect it to AutoCAD and then walk you through how to create your first skill inside Claude. This video is purely for someone who's actually getting started. I'm also assuming you'd have basic computer literacy. For example, creating an account in Claude, downloading and installing Claude Desktop, and also setting up billing. Most of this is straightforward. It's basically following the steps. I'll show you the key steps like where to download it from and also where to create your account, and also some important steps along the way. There are definitely more advanced ways how you could do this, like setting up in VS Code your CLI. I'm intentionally not going to do that because I want to keep it very simple, where you download Claude and you set up your first skill. Also, keep this in mind, you need a paid account for Claude. If you're not ready for that yet, you can go to my other video, which is the free alternative to this, which is Google Antigravity. You can go to that video and understand what agentic workflows are and have a feel for it and then come back. The link is in the description below. I will cover more advanced setup like using it in VS Code, and also the broader business case behind using these skills in your work in a future video. So hit that subscribe button because you might not want to miss it. So in order to install Claude, if you don't have it downloaded already, what you do is first go to claude.ai/download slash. I'll put it in the description below, and you come here and then you click on download. I have Windows and I'm going to click Windows. Downloading. Now open file. That's it. Basically, it took my previous account and started it. Now, if you don't have an account already, what you do is you close this, you go to claude.ai, and either you can continue with Google. If you have a Google account, that's pretty easy. You click on it and it will create your account. Like I said, to use Claude Skills, you would need a paid account. It could change in the future because I've seen Anthropic in the past expanding their offerings for free users as well. But coming back, you could enter your email. I'm going to go with, say, admin@sexlabs.com. Continue with email, and then the link will be sent into your email ID. You can copy and paste it here, and your account will be there. Okay, that's it. They have made it really, really simple. Now, once you have set up your account, You're going to close it. Then you are going to see this folder. This is what is there in the link below. This is the set framework completely set up for you. So after downloading this folder, you are good to go. So what I'm going to do is I'm going to click on this download all. So it's preparing the zip folder. Okay, so it's downloaded. I'm going to close this now. I've opened my zip folder here from the downloads. You could either put it into your desktop or wherever you'd like to put it. I'm just going to put it in my desktop here. I'm going to close it. Now I'm going to open Claude. Now, after opening Claude, you need to go to code. This is chat. Then you have Claude code, or you could press Control+3. This is the chat window. And then if you go Control and 3, you go to Claude code. That's where you need to be. Right now, this is my other folder, but I'm going to show you where you can do it as well. So you're going to go here to the bottom, design and draft, choose a different folder, and you're going to go to where your folder is. This is design and draft. And then you're going to click on it, select folder. That's it. So now you have that folder with all the files, all the background information required in there. What you're going to do? Now, let me open my CAD. That's it. I'm just going to open like a template, a new simple drawing. I'm going to say, are you connected to my AutoCAD? Trust workspace. I trust it because I created it. So test the connection. Okay, test the connection. Don't worry, because there's a skill in there to actually check the connection. Always allow, and it would run everything. That's it. Hello from Claude. You are connected to AutoCAD. Congratulations, you right now have connected your Claude instance to your AutoCAD. Before we get into the system, let me explain the three things you need to know: Claude, Claude Code, and Claude Skills. If you have never touched AI before, that's fine. This is the only explanation you need. Claude is the brain. It's an AI that can read, reason, and write. Think of it as a very fast graduate engineer. It can read any document you give it, it can understand engineering context, but just like a real graduate, it's smart, but it's useless on its own. It needs a manual and it needs tools. Claude Code is built into Claude Desktop. It's the part that lets Claude actually do things on your computer: run scripts, open files, execute commands, send instructions to AutoCAD. Without Claude Code, Claude is just a chatbot. It can talk, but it cannot act. Claude Code gives it hands. Claude Skills is where it all comes together. A skill is a file you create, a .skill file, that acts as an instruction manual, plain English, step by step. It tells Claude, here are the inputs to expect. Here are the scripts to run. Here's the order. Here's what to check. You pay that .skill file with Python scripts, the actual tools that do the work, and now Claude has everything it needs: a brain that can reason, hands that can act, a manual that tells it what to do, and tools to do it with. Now, that's the product explanation. Let me give you the framework that makes it easy to remember. I call it SET: Skills, Engine, Tools. And once you understand SET, everything else in this video will make sense. Don't worry, it's just a folder structure. S is for skills. That's the .skill file we just talked about. The instruction manual written in plain English. It tells the system, here are the inputs I expect, here are the scripts to run, here's the order, here's what to check, here's where to save the output. Think of it like your company's design procedure document. Step-by-step instructions that anyone can follow. Except, instead of a person following them, the engine does. E is for engine. That's Claude, with Claude Code giving it hands. The brain that reads the skill, makes decisions, and codes the tools in the right order. Same graduate engineer analogy. Smart, can read anything, can follow instructions, but needs the manual and the software to be useful. T is for tools. These are the Python scripts that do the actual work. They run the design calculations, they generate the PDF reports, they send drawing commands to AutoCAD. Here's the critical thing: the engineering logic, your formulas, your code checks, your design rules, that all lives in the tools and not in Claude. Claude doesn't calculate anything. Claude reads the skill, then calls the tools in the right order. The tools do the maths. So the whole system is, you give Claude a skill, the instruction manual, Claude reads it, understands the workflow, Claude calls the tools, the Python scripts, in the order the skill specifies. The tools do the actual engineering work, and the output lands like a PDF calc sheet, an AutoCAD drawing, or both. Brain plus manual plus tools. That's SET. As I said before, skills is in a folder. All your skills would be in one folder. Then you have tools. All your tools would be in another folder. Now I said the tools are Python scripts. And I know some of you just thought, I don't know Python, I don't code. Stay with me. You don't need to write Python from scratch. Remember, your engineering logic already exists in your spreadsheets. All we are going to do is translate it. And you're going to see later in the video how I do it. But before that, let me explain why we use Python and not just keep the Excel spreadsheet. Here's a simple way to think about it. Excel is a calculator sitting on your desk. Okay? You punch in the numbers, you read the screen, and you walk over to the drafting table and draw. There's a gap. You are the bridge between the calculator and the drawing. Python is like a robotic arm connected to both your calculator and your drafting table. It punches in the numbers, reads the results, and draws, all in one motion. You don't need the robot arm to be smarter than the calculator. You need it to be connected. That's the difference. With Excel, Claude can't reliably close the loop. Wrong cell references, broken links, hidden sheets, version conflicts, etc. Excel is fragile when you try to automate it. With Python, Claude calls one script, same input always gives the same output, no silent formula errors on anything of that sort. Know which version of the spreadsheet is this. And it connects directly to AutoCAD. The spreadsheet logic is easy to convert. So the same formula, same checks, just translated into a format that Claude can call and AutoCAD can receive. And like I said, your Excel spreadsheet does not go anywhere. It becomes your benchmark, the thing you test against. Let's set up the system. Customize. Skills. I've got like an existing skill there, but you can ignore that. Let's create a new one. Create with Claude. I'm dropping my spreadsheet. D R A W. Defining the task. Need to turn this spreadsheet into a skill. Turn this into a Python script. Then need to plot them in AutoCAD. Rules. What are the rules it needs to follow? Do not calculate anything yourself. Use the spreadsheet logic. Interpret results and then draft in AutoCAD. Assets. What are the assets? Concrete in SConc layer. Steel in SREO. Text in SText. I'm just gonna add some colors as well so we can see it. Blue. Rio should be in red. Text be in yellow. Now what success looks like. I'll just fix this. Anything spreadsheet. What success looks like. I need to say, hey, wait. You need to design using the Python scripts and then draft it in AutoCAD. I'll add something more in rules. First, do the spreadsheet to Python and then change it to no, and then put them in a no. Create a PDF for future checks. The PDF must be readable. Oh, couldn't find it, but that's okay. It doesn't matter as much. I guess this should be it. Sonnet 4.6. Click enter. Just do axial only case for now because I've got like two details, two types of spreadsheets in there, so I just want only one sheet. Use the attached PF design spreadsheet for design logic. Enter. Now you're going to see how it's going to create the whole skill. Always allow for project, which is local. Yeah, it needs pandas and OpenPyXL. OpenPyXL is to analyze the spreadsheet. Always allow. So basically read my spreadsheet. Allow. Again, always allow. Always allow. Always allow. You can see excerpts from my spreadsheet. Okay, not okay. So it's reading these formulas in the background. Always allow. It's gonna ask a couple of times. Again, run. You can also see the tokens that's being consumed and how many minutes it's taking. Always allow. Yes. Now let me verify the calculation against the spreadsheet values. Okay, go ahead. Always allow. It's got some test values in the because of weight, allowable bearing pressure, F prime C. Always allow. Again, this is like a very simple spreadsheet. Now creating generate PDF. So it has created these to-dos in there. So first was creating the pad footing design.py for the calculation, and then now creating another Python file to generate the PDF. That's what it's working on now. After that, there's another tool which is it's going to create, which is draw AutoCAD.py. Then it then packages it into a skill, and that skill would then be tested against the results. Now it's testing the PDF. Okay, let's see. Allow. Always allow. Some error. Don't worry, it's going to fix it. Always allow. PDF is open for review. Now the AutoCAD drawing script. Let's have a look at the PDF. Okay, here's the PDF. All checks passed. It just took the values from my own spreadsheet. I had like some typical values in there. Okay, 8 and 16s, yeah. All of it will be passed. Yeah. Pass. Yeah, well, this is not like a structural design uh, course or anything. It's basically my spreadsheet. It converted it. Okay, I'm going to close it. So now it's creating the pad footing.skill. Or already created the AutoCAD script as well. That's it. So skill is created. Now the log test case. Now it's creating test cases to make sure that this thing works. Always allow. All 31 checks pass at 0% error. It would be 0% because the spreadsheet had very straightforward formulas. So it will actually work. The other thing you should be doing is, okay, so here's the folder structure, tests, run log.py, test one input. Okay. So I had like few benchmark inputs, which I can use. Now I'm just going to copy this. As you can see, it's pad footing design. I can look at the test cases, expected results, and it verified with it. So it's working. I'm going to go to skills. There's my pad footing.skill. Tools, pad footing. That's it. That's where it is. Including the test cases. Projects, it will be empty, depending on which project I'm working on. VJN is like my way of working. New session. Maybe not. I'm going to continue the same one. You can just go with new session if you want, if you like, but I'm just going to continue it here. Always allow. Basically, it failed because the minimum reinforcement. Okay, so it failed at that. So which we've got two options. Either we could use 8 and 20s each way or 11 and 16s each way. I'm going to go with option A. Copy, paste. Always allow. Always allow. Oh, this is like my broader template, by the way. As you can see, that's the column, text in yellow, concrete in blue, Rio in red. That's it. Always allow. Generating the PDF and drawing in AutoCAD. Okay, it's pretty good, I'd say. If you look at the token usage from before, it was only a couple of hundred tokens, by the way. $2,500 by $2,500 by 600 thick, 8 and 20s. S concrete, S conc. Now I'm going to go to projects, VJN002. Here's the calc sheet. I'm going to open it. Okay. So here I could come in and check all the values that has been used. Again, like I said, this is not a structural design. Where do you go from here? I want you to think about your own spreadsheets right now, the ones you open every week. Which ones follow that pattern? Numbers in, pass or fail, then a drawing. I don't know, you might know it because it's your spreadsheet. Every one of those is basically a skill waiting to be built. And it starts with what you already have. Your spreadsheets, your engineering logic. You're not learning to code from scratch. You're translating knowledge you already built into a format that Claude can run and AutoCAD can receive.